When running a subpanel to a detached garage from a house with a 200 amp single-phase 3-wire service, a ground wire must be run with the conductors to the subpanel. The National Electrical Code, or NEC, addresses this situation to ensure proper grounding and electrical safety. Although a grounding electrode system at the garage might seem like an alternative, it is not a substitute for running a ground wire from the main panel. The NEC mandates specific grounding requirements for both the supply side, meaning the service entrance at the house, and the load side, which is the subpanel in the garage. The primary purpose of the ground wire, also known as the equipment grounding conductor or EGC, is to provide a low impedance path for fault current to return to the source, which is the main panel. This low impedance path facilitates the rapid operation of overcurrent protective devices such as circuit breakers or fuses in the event of a ground fault. Without an effective ground path, fault currents may not be cleared quickly, leading to potential hazards such as electrical shock, fire, and equipment damage. Section 250.32 of the NEC covers grounding requirements for detached buildings or structures. This section emphasizes the need for an equipment grounding conductor to be run with the supply conductors to the detached building. While a grounding electrode system is also required at the detached building, it serves a different purpose. The grounding electrode system, typically consisting of ground rods, ground rings, or other approved electrodes, is intended to establish a connection to the earth. This connection helps to stabilize the voltage to earth and provide a path for lightning and other transient voltages to dissipate. It is important to understand that the grounding electrode system alone cannot provide the low impedance path necessary for clearing ground faults. Therefore, running a ground wire from the main panel to the subpanel is essential for safety. The ground wire should be sized according to NEC Table 250.122, based on the size of the overcurrent protective device protecting the circuit. For example, if the subpanel is fed by a 60 amp circuit breaker, the ground wire must be at least a number 10 American wire gauge copper conductor or a number 8 American wire gauge aluminum conductor. When the conductors are buried in PVC conduit, all 4 conductors, including the hot, neutral, and ground wires, must be run together within the same conduit. This practice ensures that the inductive reactance of the circuit is minimized, which helps to reduce voltage drop and improve the efficiency of the circuit. Additionally, the neutral conductor at the subpanel must be isolated from the enclosure and the grounding system. This means that the neutral bus bar in the subpanel should not be bonded to the metal enclosure or to the grounding electrode system. The purpose of isolating the neutral is to prevent neutral current from flowing through the grounding system. If neutral current were to flow through the grounding system, it could create a voltage difference between the grounding system and earth, which could be a shock hazard. The NEC provides specific rules for connecting the grounding electrode system to the subpanel. Typically, a grounding electrode conductor, sized according to NEC Table 250.66, is used to connect the grounding electrode system to the grounding bus bar in the subpanel. The grounding electrode conductor should be run in a continuous length without any splices or joints. It is crucial to use appropriate connectors and hardware for making grounding connections. The connectors and hardware must be listed for grounding purposes and compatible with the materials being connected. For example, when connecting a copper grounding electrode conductor to a ground rod, a listed copper ground rod clamp must be used. In summary, when running a subpanel to a detached garage, both the ground wire and the grounding electrode system are required. The ground wire provides the low impedance path necessary for clearing ground faults, while the grounding electrode system helps to stabilize the voltage to earth and provide a path for lightning and other transient voltages. The neutral conductor at the subpanel must be isolated from the enclosure and the grounding system. All grounding connections must be made with listed connectors and hardware. Following these guidelines ensures a safe and effective grounding system for the subpanel in the garage. To further clarify the NEC requirements, let's delve into specific sections that address grounding and bonding in detached structures. NEC Section 250.32, Buildings or structures supplied by a feeder or branch circuit, is particularly relevant. It states that an equipment grounding conductor, EG, must be run with the supply conductors to the detached building. This EGC must be connected to the grounding electrode system at the detached building, if one exists. This means that even if you install ground rods at the garage, you still need to run a ground wire from the main panel in the house. The size of the equipment grounding conductor is determined by NEC Table 250.122, as mentioned earlier. This table specifies the minimum size of the EGC based on the rating of the overcurrent protective device protecting the feeder or branch circuit. For instance, if the feeder to the garage is protected by a 30 amp breaker, the minimum size of the copper EGC is number 12 American wire gauge. If the feeder is protected by a 60 amp breaker, the minimum size of the copper EGC is number 10 American wire gauge. NEC Section 250.50 Grounding Electrode System outlines the requirements for establishing a grounding electrode system. It states that all grounding electrodes that are present at the building or structure must be bonded together to form the grounding electrode system. Common grounding electrodes include ground rods, metal underground water pipes, and concrete encased electrodes, also known as U for grounds. If you install ground rods at the garage, you must ensure that they are bonded together with a grounding electrode conductor. The size of the grounding electrode conductor is determined by NEC Table 250.66. This table specifies the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. For example, if the service entrance conductors are number 2 American wire gauge copper, the minimum size of the copper grounding electrode conductor is number 6 American wire gauge. It is important to note that the grounding electrode system is not intended to carry significant amounts of current under normal conditions. Its primary purpose is to provide a path for fault current in the event of a ground fault and to stabilize the voltage to earth. The equipment grounding conductor, on the other hand, is designed to carry fault current back to the source, allowing the overcurrent protective device to trip and clear the fault. In addition to the grounding requirements, bonding is also an important aspect of electrical safety. Bonding refers to the practice of connecting all metal parts of the electrical system together to create a low impedance path for fault current. This includes metal enclosures, metal conduits, metal water pipes, and other metal parts that could become energized in the event of a fault. NEC Section 250.92 Bonding jumpers and clamps provides requirements for bonding metal parts of the electrical system. It states that bonding jumpers must be used to connect metal parts together and that the bonding jumpers must be sized according to NEC Table 250.102. For example, if you are bonding a metal conduit to a metal enclosure, you must use a bonding jumper that is sized according to NEC Table 250.102 based on the size of the circuit conductors in the conduit. It is crucial to ensure that all bonding connections are made with listed connectors and hardware. The connectors and hardware must be compatible with the materials being connected and must be properly installed. Improperly installed bonding connections can create a high impedance path for fault current, which can increase the risk of electrical shock and fire. In summary, when running a Subpanel or detached garage, it is essential to comply with all applicable NEC requirements for grounding and bonding. This includes running an equipment grounding conductor with the supply conductors, establishing a grounding electrode system at the detached building, and bonding all metal parts of the electrical system together. Following these guidelines ensures a safe and effective electrical system for the garage and protects against electrical shock, fire, and equipment damage. Furthermore, it is beneficial to discuss the specific components used in a grounding electrode system. The most common components are ground rods, typically made of copper-clad steel, and ground wires, which are typically solid or stranded copper conductors. The ground rods are driven into the earth to provide a connection to ground, while the ground wires connect the ground rods to the electrical system. The NEC specifies the minimum length and diameter of ground rods. Typically, ground rods must be at least 8 feet long and 5/8 inch in diameter. The ground rods must be driven into the earth so that at least 8 feet of the rod is in contact with the soil. If bedrock is encountered, the ground rods can be buried horizontally in a trench that is at least 30 inches deep. When installing ground rods, it is important to ensure that they are properly spaced. The NEC recommends that ground rods be spaced at least 6 feet apart. This spacing helps to ensure that the ground rods are effective in dissipating fault current and stabilizing the voltage to earth. The ground wires used to connect the ground rods to the electrical system must be sized according to NEC Table 250.66, as mentioned earlier. The ground wires must be connected to the ground rods using listed connectors. Common types of ground rod connectors include ground rod clamps and exothermic welds. Ground rod clamps are mechanical connectors that clamp the ground wire to the ground rod. Exothermic welds are a type of welding process that creates a permanent connection between the ground wire and the ground rod. In addition to ground rods and ground wires, other types of grounding electrodes can be used. These include metal underground water pipes, concrete encased electrodes, and ground rings. Metal underground water pipes can be used as grounding electrodes if they are in direct contact with the earth for at least 10 feet. Concrete encased electrodes, also known as U for grounds, consist of at least 20 feet of bare copper conductor encased in concrete. Ground rings consist of a bare copper conductor buried in a trench that encircles the building or structure. When using any type of grounding electrode, it is important to ensure that it is properly installed and connected to the electrical system. The grounding electrode must be in good contact with the earth and must be connected to the electrical system using listed connectors and hardware. Improperly installed grounding electrodes can be ineffective in dissipating fault current and stabilizing the voltage to earth. To further enhance understanding, let's consider a practical example of how to ground a subpanel in a detached garage. Suppose you are running a 60 amp feeder from the main panel in the house to a subpanel in the garage. The first step is to install 2 ground rods at the garage, spaced at least 6 feet apart. The ground rod should be driven into the earth so that at least 8 feet of each rod is in contact with the soil. Next, connect the ground rods together using a number 6 American wire gauge bare copper conductor. This conductor is the grounding electrode conductor. Connect the grounding electrode conductor to the grounding bus bar in the subpanel. The grounding bus bar is a metal bar in the subpanel that is specifically designed for connecting grounding conductors. Run a number 10 American wire gauge insulated copper conductor from the main panel in the house to the subpanel in the garage. This conductor is the equipment grounding conductor. The equipment grounding conductor should be run with the feeder conductors in the same conduit. Connect the equipment grounding conductor to the grounding bus bar in the subpanel. Ensure that the neutral bus bar in the subpanel is isolated from the enclosure in the grounding system. This means that the neutral bus bar should not be bonded to the metal enclosure or to the grounding electrode system. Finally, test the grounding system to ensure that it is working properly. Use a ground resistance meter to measure the resistance between the grounding bus bar and the subpanel and earth. The resistance should be less than 25 ohms. If the resistance is greater than 25 ohms, additional grounding electrodes may be required. By following these steps, you can ensure that the subpanel in the garage is properly grounded and that the electrical system is safe and effective. It is always advisable to consult with a qualified electrician to ensure that all electrical work is performed in accordance with the NEC and local codes. Proper grounding and bonding are essential for electrical safety and can help to prevent electrical shock, fire, and equipment damage. Remember, electrical work can be dangerous and should only be performed by qualified individuals. If you are not comfortable performing electrical work, it is best to hire a licensed electrician to do the job. Furthermore, it's important to understand the difference between grounding and bonding. While the terms are often used interchangeably, they have distinct meanings and purposes. Grounding, as discussed earlier, refers to connecting the electrical system to the earth. This is typically accomplished by installing grounding electrodes, such as ground rods, and connecting them to the grounding bus bar in the electrical panel. The purpose of grounding is to provide a path for fault current in the event of a ground fault and to stabilize the voltage to earth. Bonding, on the other hand, refers to connecting all metal parts of the electrical system together to create a low impedance path for fault current. This includes metal enclosures, metal conduits, metal water pipes, and other metal parts that could become energized in the event of a fault. The purpose of bonding is to ensure that all metal parts of the electrical system are at the same potential, which reduces the risk of electrical shock. In summary, grounding connects the electrical system to the earth, while bonding connects all metal parts of the electrical system together. Both grounding and bonding are essential for electrical safety and should be performed in accordance with the NEC and local codes. It's also crucial to use the correct wiring methods and materials when installing a subpanel in a detached garage. The wiring method refers to the type of wiring used to connect the main panel to the subpanel. Common wiring methods include conduit, such as PVC or rigid metal conduit, and cable, such as underground feeder or off cable. The choice of wiring method depends on several factors, including the location of the subpanel, the type of building construction, and local codes. Conduit is typically used when the wiring is exposed or when it needs to be protected from physical damage. Cable is typically used when the wiring is buried underground or when it is concealed within walls or ceilings. When using conduit, it is important to ensure that it is properly installed and supported. The conduit must be securely fastened to the building's structure and must be protected from physical damage. When using cable, it is important to ensure that it is properly buried or supported. UF cable must be buried at least 24 inches deep and must be protected from physical damage. In addition to the wiring method, it is also important to use the correct type and size of conductors. The conductors must be sized according to the load that they will be carrying and must be rated for the voltage and temperature of the application. Copper conductors are typically used for electrical wiring, but aluminum conductors can also be used in some cases. When using aluminum conductors, it is important to use connectors that are specifically designed for aluminum conductors. Aluminum conductors can corrode if they are not properly connected, which can lead to electrical problems. Finally, it is important to use listed electrical components. Listed electrical components are components that have been tested and certified by a recognized testing laboratory such as Underwriters Laboratories or UL. Listed electrical components are safer and more reliable than non-listed components. When installing a subpanel in a detached garage, it is essential to use listed circuit breakers, listed wiring, listed connectors, and listed grounding components. This will help to ensure that the electrical system is safe and effective. In conclusion, running a subpanel to a detached garage requires careful attention to detail and compliance with all applicable codes and regulations. By following the guidelines outlined in this discussion, you can ensure that the subpanel is properly grounded, bonded, and wired, and that the electrical system is safe and reliable. Remember to consult with a qualified electrician if you have any questions or concerns about electrical work.